faithfully delivering value and interpreting great books from around the world. Hello, this is Sally's Book Talk. Today's book for you is Cosmos. What are your imaginations about the vast cosmos? Welcome to share your thoughts in the comments section. Cosmos is a book with some age. It was first published in 1980, and over 40 years have passed. This book has long become a classic in the popular science field. Nowadays, countries worldwide are racing to develop aerospace technologies. Our country has achieved major feats like the Tianwen-1 landing on Mars and the establishment of the Tiangong space station. Humanity is accelerating into the space age. Perhaps now is the perfect time to pick up this work and re-examine humanity's ideals and ambitions for reaching the cosmos. Wow. The author of this book is the renowned astronomer Carl Sagan, who was the president of the Planetary Science Division of the American Astronomical Society and published over 600 academic papers in his lifetime. He also served as a long-term science advisor for NASA and led space projects like the Voyager missions and the Golden Record. And beyond academic achievements, Sagan was an outstanding science educator, planning and publishing influential popular science works that shaped generations' understanding of science. And the famous physicist Stephen Hawking invited Sagan to write the foreword for A Brief History of Time. In the foreword, Chinese physicist Li Miao directly commented that in the past century, there's been no better science popularizer than Sagan, and this book, Cosmos, is one of his representative works. In 1980, Sagan led the production of a TV program called Cosmos, popularizing scientific knowledge in astronomy, physics, and other fields. The program was a huge success, attracting 500 million viewers globally. As a derivative of this program, the book was equally popular upon release, topping the New York Times bestseller list for 70 consecutive weeks. The New York Times described the book as charming and imaginative. Liu Cixin, the famous sci-fiction author of The Three-Body Problem, once said that Cosmos opened his third eye to science. There are natural reasons why this book has garnered such high praise. The book explores not just the astronomical universe. Its original English title is Cosmos, and the deeper meaning of this word is order. Through this book, Sagan aimed to express an understanding of the order in all things. The book's content also covers knowledge from multiple disciplines like astronomy, physics, biology, history, and engineering. What's even more admirable is that Sagan didn't coldly present scientific principles. His writing is filled with beauty and romantic sensibility. Thus, this book is a rare masterpiece in popular science. This interpretation condenses the book's content into 3 parts, each presenting Sagan's understanding of life, civilization, and the cosmos. These 3 grand themes. All right, let's follow Sagan, this great guide, and embark on this cosmic journey. First, we'll discuss life. Sagan himself had an extraordinary interest in this topic. He once conducted research in the laboratory of American biologist Herman Muller. After entering astronomy, Sagan devoted immense passion to searching for extraterrestrial life, giving him deep insights into life-related questions. In this book, Sagan guides us through Earth life's origin and evolution, while boldly imagining forms of alien life. First, the origin of life. To Sagan, life emerging on Earth is profoundly miraculous, and humanity's birth represents a 4-billion-year journey of uncertainty. Earth's life consists of organic molecules, but how did these molecules appear? This takes us back to Earth's birth, about 4.6 billion years ago. In our solar system, countless dust particles gradually coalesced to form primordial Earth. During Earth's infancy, terrifying lightning storms persisted in the sky, combined with intense solar radiation. This shredded gas molecules in the primordial atmosphere into fragments that dissolved in early oceans, creating a thick, soupy sea. In this primordial soup, molecules continually broke apart and recombined. After hundreds of millions of years, extraordinarily special molecules emerged that could replicate themselves. Their descendants became DNA. Today we know DNA is a double helix molecule, primarily composed of 4 bases. This structure allows DNA to carry genetic information. Around these early DNA molecules, other molecules gradually gathered, forming cells, the first life. Currently, we know of tens of billions of organic molecule types, yet only about 50 participate in life's fundamental processes. And so the diverse life forms on Earth are essentially permutations and combinations of these 50-plus organic molecules. Flowers, grass, cats, dogs, and humans all share the same molecular ancestors. Now let's return to early Earth another billion years later. 3 billion years ago, cells that should have been solitary suddenly clustered together and began cooperating. This phenomenon likely resulted from DNA replication mutations, leading to Earth's first multicellular organism. Looking at ourselves, the human body is actually a collection of tens of trillions of cells that once operated independently, but now unite to form you and me. After another billion years, sex differentiation began among cellular organisms. The advantage of sex is that organisms can exchange large segments of DNA information, dramatically accelerating evolution. Now, following sexual emergence, another billion years passed. By then, marine photosynthesis had transformed Earth's atmosphere with oxygen. With sufficient oxygen, Earth reached a crucial evolutionary milestone. 600 million years ago, new life forms began emerging in abundance. This period is known as the Cambrian explosion. Previously, Earth only had simple plants like cyanobacteria. During the Cambrian explosion, numerous animals with complex organs appeared. Suddenly, oceans teemed with bizarre creatures. Most representative were trilobites, emerging 500 million years ago and resembling oversized cockroaches. These trilobites roamed oceans in swarms, dominating Earth for 300 million years.
Then new species accelerated. Fish swam waters while plants, animals, and insects colonized land.
Amphibians and reptiles emerged next, introducing large land animals. Soon dinosaurs appeared, ruling as Earth's dominant species for 160 million years. During this era, birds first took flight, while mammals scurried under dinosaurs until 65 million years ago, when asteroid impacts or volcanic eruptions caused global catastrophe, devastating flora and fauna, until food-deprived dinosaurs went extinct. But mammals survived through small size and dietary flexibility, becoming Earth's protagonists and evolving the first human-like species 10 million years ago. Then, over a million years ago, true humans finally emerged. The birth and evolution of life on Earth has been magnificent, and Sagan highly revered Darwin's theory of evolution. He emphasized that the secret of evolution lies in small mutations adapting to the environment. As time accumulated, species failing to adapt were eliminated, evolving from a single cell in the primordial ocean to modern humans. But compared to Earth's vast history, humanity's emergence is but a fleeting moment. Sagan once wrote in the book, "We are like butterflies fluttering in daylight, mistaking the day for eternity." Before great nature, humans are but mayflies in the vast cosmos. Even with such brief existence, we should marvel at the human body. Observing ourselves reveals bodily wonders rivaling the galaxy stars. Things we take for granted daily are utterly miraculous upon reflection. Writing down all human DNA information could fill 1,000 books. More remarkably, during cell division, DNA replicates this vast data with near-perfect accuracy, errors being extremely rare. Another example. With just 20 amino acid types, cells create diverse proteins enabling energy absorption, growth, healing, and disease resistance. Thus, humans are exquisite machines, fine-tuned over 4 billion years. Given this understanding, can we imagine extraterrestrial life through Earth's lens? Sagan dedicated his life to searching for extraterrestrial life. What might extraterrestrials look like in his view? Science fiction writers often model aliens after Earth life. larger eyes, extra limbs, or green skin. But Sagan was skeptical of such alien forms. Sagan openly admitted he couldn't definitively describe extraterrestrial beings, but he believed alien life must match its planetary environment. For example, on a gas giant like Jupiter, with hydrogen, helium, and ammonia atmosphere covered by thick clouds, what might life there resemble? The primary challenge for life here would be high temperatures, because in such atmospheric conditions, the greenhouse effect would be extremely intense. So, according to Sagan, life here must learn to use air currents to rise higher for cooling, avoiding descent where they'd be cooked. For this environment, Sagan first envisioned creatures called floaters, like giant balloons suspended in the planet's sky. These floaters are enormous, even larger than Earth's whales. They'd consume airborne molecules or sunlight-dependent microorganisms, expelling heavier gases like helium while retaining hydrogen for buoyancy. They can also move rapidly through jet propulsion, but mostly they drift quietly. To maintain ecological balance, another creature called hunters would exist here. These would be small, agile creatures. They specialize in hunting floaters, obtaining food while extracting hydrogen to maintain their own suspension. Though fantastical plausibility, floaters and hunters are plausible life forms deduced from environmental conditions. When imagining aliens, don't be limited by Earth's frameworks. Extraterrestrial life must be wildly diverse. Any physics-compliant concept could exist. Of course, advanced life develops intelligence, forming civilizations, which are more complex than life itself. So how does Sagan view extraterrestrial civilizations? That's exactly part two's topic. Discussing alien civilizations requires evidence-based reasoning. Sagan defined civilization as a species possessing radio astronomy knowledge and building devices like radio telescopes. This high standard ensures civilizations can detect or transmit cosmic signals. To calculate such civilizations' probability, Sagan introduced a mathematical formula proposed by American astronomer Frank Drake, Sagan's colleague and close friend. Sagan frequently referenced this formula in his works. Specifically, this formula calculates the possible number of civilizations in our Milky Way galaxy. This value can be estimated by multiplying several parameters. Representative parameters include the galaxy's total stars, probability of stars having planets, and average planets per star. Also, the probability of habitable planets evolving intelligent life, and so on. Many parameters are already known. For example, there are about 400 billion stars in the Milky Way, many with planetary systems. Sagan estimated such stars comprise about 1/3 of the total. Assuming these systems resemble ours with 10 planets each, the galaxy would contain over 1 trillion planets. Thus, the universe is truly a grand stage. Of course, many parameters remain difficult to estimate, like the probability of intelligent life evolving. As discussed in part 1, life's emergence is complex and contingent, making probability estimation nearly guesswork. Certainly, life's basic molecules form under ordinary conditions. Sagan believed, given sufficient time, billions of years, these molecules have high probability of forming life. However, this refers to microbial life. Other parameters concern technological development. If life endures long enough to develop intelligence and appropriate technology, civilizations may mature. Sagan provided his own analysis and speculations about these processes. In summary, using the most optimistic parameters, there might be millions of civilizations in the Milky Way. The nearest civilization might be within 200 light years, a truly astonishing inference. So, if extraterrestrial civilizations exist and approach Earth in spacecraft, how should we interact? Earth's history shows that when civilizations meet, the less advanced often face destruction. For example, between the 14th to 16th centuries, the Aztec civilization existed in what's now Mexico. They have magnificent architecture, a unique cultural heritage, and exquisite works of art. But in the 16th century, a Spanish army of only about 400 men defeated this ancient civilization with a population of millions, because the Aztecs couldn't ride horses and didn't use iron in warfare. Whereas the Spaniards were already equipped with powerful weapons like firearms. In fact, the technological gap between the Aztec and Spanish civilizations was only a few hundred years. If we were to actually contact an extraterrestrial civilization, humanity would likely be the less advanced party, because any civilization more primitive than us hasn't developed radio astronomy. They can't contact us, while those capable of finding us have advanced technology and at least possess the capability for interstellar travel spanning hundreds of light years. In some sci-fi novels or movies, if aliens are invaders, their military strength is usually portrayed as superior to Earth's. For example, they have faster spaceships or more powerful cannons, but humans often rely on wisdom or unity to crush the aliens' ambitions. But Sagan bluntly points out in the book that two space civilizations are almost impossible to interact on an equal level. Theoretically, if violent conflict occurs, one side will inevitably overwhelm the other. So, if one day an alien army suddenly appears on Earth, their technology would be far superior to ours. If they wanted to invade Earth, we'd be defenseless. But humans don't need to live in fear. There's some good news here, because certain natural laws might limit aliens' ambition to invade Earth. First, to achieve interstellar travel technology, a civilization must constrain its population. Because if population growth is unchecked, a single planet's resources would only sustain survival, even leading to overexploitation. This phenomenon is universal, as evidenced by the development of various human civilizations. No matter how alien life might be, to maintain a healthy civilization and social stability, they must control population within reasonable limits. Thus, civilizations capable of interstellar travel must have populations in a state of slow or zero growth. And for a species with slow population growth to conquer Earth would take an extremely long time. Because after finding suitable planets, they'd need time for development before moving onward. Sagan and colleagues calculated, if a low population growth civilization emerged 200 light-years away and slowly expanded toward Earth, colonizing habitable planets en route. A 200 light-year radius sphere contains 200,000 stars and millions of explorable planets. Logically, these aliens would colonize all planets along the way before noticing Earth. This journey would take at least 1,000,000 years, a substantial time frame. Human civilization is barely tens of thousands years old, ample time to develop defenses. If advanced aliens came directly, don't panic, they'd view us like we view monkeys. Would such an advanced civilization even care about invasion and colonization? After all, by the 21st century, humanity already rejects such violent tendencies. If aliens truly arrived, they'd likely remain calm and peaceful. So regarding alien civilizations, cautious optimism suffices. No need for undue worry. Sagan believed even with risks, humanity must explore deeper space, not stagnate. He personally led or participated in major space research projects. In Part 3, we'll examine human space exploration and Sagan's view of our cosmic relationship. Currently, humanity explores space through two primary methods: signal-based observation and dispatching methods description, and dispatching probes to directly reach celestial bodies. These probes float silently while constantly emitting signals. These signals include visible light, X-rays, and various electromagnetic waves. By collecting these signals, we gain valuable insights. For example, Venus was long believed to have life-friendly surface temperatures. But by studying Venus's radio waves, Sagan shattered that illusion, calculating its surface temperature at 500 degrees Celsius. In 1962, the Mariner 2 probe confirmed Sagan's assessment of Venus. Another example, though no spacecraft has landed on the Sun, studying its spectrum and electromagnetic signals reveals it's mainly hydrogen and helium, with 6,000 degrees Celsius surface temperature and 15 million degrees Celsius internal temperature. Detailed-based methods remain indirect. Detailed planetary study requires landing probes directly. Undoubtedly, the Moon has the most landings. Humans even walked its surface. But Sagan's greatest interest was Mars, long speculated to harbor life. Geologically, Mars resembles Earth remarkably.
It features mountains, plains, canyons, even surface grooves once mistaken for ancient canals.
To investigate closely, 1970s humanity launched two Mars probes, Viking 1 and Viking 2. These Vikings aimed to land directly and reveal Mars' true appearance. After landing successfully, the Vikings quickly transmitted first photos to Earth. Sagan described his awe upon seeing the first Martian horizon photo. He remarked Mars felt familiar, rocks and sand indistinguishable from Earth's. He even joked that a prospector with a mule emerging from dunes wouldn't surprise him. Disappointingly, photos showed no surface life signs. But perhaps Martian life hides as subsurface microbes. After all, Earth was microbial dominated for 3 billion years. The Vikings anticipated this.
They featured a robotic arm to scoop soil into specialized analyzers.
These analyzers detected specific organic molecules typically produced by biological metabolism. Initial results thrilled, molecular signals detected, but joy was short-lived. Soon, scholars noted that a unique compound in Martian soil could produce these molecules under certain conditions. DEPI, the Viking experiment, couldn't determine if molecules came from soil or microbes. So we still can't confirm whether life exists on Mars.
But Mars isn't our final destination.
Sagan believed humanity should venture farther. He proposed a bold concept: launching spacecraft beyond our solar system carrying information about humanity. If extraterrestrial civilizations found it, they could learn about us. This vision launched in 1972. That year, America launched Pioneer 10, carrying a metal plaque showing humanity's location in the Milky Way. In 1977, two more advanced probes launched, Voyager 1 and Voyager 2.
These probes carried golden records toward deep space.
The records contained 60 human greetings, 90 minutes of music, and Earth civilization introductions. Made of durable materials, cosmic rays would take over 1 billion years to degrade these records. Carrying humanity's self-introduction, the Voyagers journeyed into cosmic depths. Humanity's extensive space program stemmed from scientific truth-seeking. But Sagan noted deeper interpretations of humanity's cosmic relationship exist. First, cosmic exploration fuels human civilization's development. For most of human history, our ancestors lacked entertainment, no TV, movies, or books. Especially at night, their only activity was stargazing. So ancestors imagined star patterns into constellations. Hunter-gatherers saw Ursa Major, Canis Major, and Orion in the stars. When 17th century Europeans sailed south, they saw the southern sky for the first time. They named constellations after compasses, peacocks, and telescopes. If placed today, might new constellations be named after phones, cars, and computers? Observing stars wasn't just passing time. It revealed to humanity an almost eternal, unchanging order. Like the sun and moon, the stars also rise in the east and set in the west. As seasons change, the stars' paths adjust accordingly. But year after year, they follow constant patterns. Naturally, people recorded this celestial order to guide farming, navigation, and other civilizational activities. Of course, tracking the sun and moon's paths had the same effect. To ancient peoples, these celestial bodies represented a timeless order, worshipped by people across every corner of the earth. In New Mexico's Chaco Canyon, there's an 11th century temple with 5 crowns. Every June 21st, the longest day, a beam of sunlight illuminates a special niche before dawn. Similar structures exist worldwide, like Cambodia's Angkor Wat, England's Stonehenge, Egypt's Abu Simbel, and Mexico's Chichen Itza. It can be said the universe taught humanity to seek patterns, evolving into the pursuit of natural science, driving civilization's progress, leading us to today. When discussing humanity's cosmic relationship, Sagan offered a romantic notion. Humans are children of the universe, with life's origin tied to stellar evolution. Many elements compose our bodies. Besides basic carbon, hydrogen, oxygen, there's iron, calcium, magnesium, and trace elements. These elements didn't appear out of thin air. Born in stars, their interiors act like giant furnaces. Through nuclear fusion, hydrogen and helium fuse into magnesium, silicon, sulfur, etc. When a star dies, it sprays elements into space. They drift, absorbed by new stars, remelted and resprayed. Thus, a rich variety of elements spread throughout the universe, and those in our solar system came about the same way. Therefore, the matter composing you, me, and everything around us was forged by the stars. The nitrogen in our DNA, calcium in our bones, and iron in our blood all come from stars. Fundamentally, we are all children of the universe. To Sagan, since we're cosmic children, returning to the universe's embrace is natural. Has this romantic notion inspired you too? Welcome to share your thoughts. Throughout the book, Sagan explores life evolution, alien civilizations, and cosmic exploration with erudition and romance. Even today, our understanding remains limited, with countless mysteries hidden in the starry sea. But undoubtedly, humanity can't remain earthbound forever. As cosmic children, we should venture into the universe with reverence. Our destination should be the stars and the cosmos. Well, that concludes our interpretation of cosmos. Reading notes are below. See you next time.